All right, class, good morning, and welcome to your lesson on the four types of forces, the four main types of forces in physics. This lesson, we're going to be able to ID the four main types of forces in physics. So, remember, these are the main types of forces, not all forces, but just the main ones. So, the first thing we have to learn is a free body diagram. A free body diagram. A free body diagram is a diagram that shows all forces acting on an object. All forces acting on an object. So what are those forces? Well, the first force is going to be gravity. This is going to be our first force, gravity. And we denote gravity typically by capital F, lowercase g, or mg. And so when we draw an object, any object, doesn't matter what, we would draw an arrow pointing down because gravity always points down, and we would put F of g right there. So that shows us that gravity is one of our forces, Fg, or we put mg right there. Either one of these works, whatever you're comfortable with. So gravity is our main number one force. Whenever you draw a free body diagram, we always, almost 99% of our problems deal with something in a gravitational field, on Earth, not in space, especially for this course. So gravity is going to be one of those forces. The next force is going to be the normal force. Normal force. And this is a compression force. This is a compression force. So if we are standing on the ground, an object is on the ground, it has gravity pulling it down. However, if gravity was the only thing acting on it, it would be in free fall. It would be falling down. Remember, a projectile is an object in which only gravity is acting on it. So if it's sitting on the ground, there's something else there, and there is a normal force pushing it up. So that is F, capital F, N, or sometimes we just write capital N for normal force. Either way, both those work. Capital N or F lowercase or F sub n. And this is a normal force. It's called a compression force. And this is why I say a compression force. Let's say, for example, you were standing on a scale. This is a scale. And you stand on it, right? This is your foot. Okay? You have no toes. Okay? You were born with webbed feet. Sorry about that. You're a good swimmer, though. And you are standing on a scale, and there are springs under there. So there are springs, and those springs get pushed down slightly, and they push you back up. So these springs are pushing you back up, and how much you push them down determines how much you weigh. So, but what's really keeping you from moving there? It's a normal force. You are compressing it down, and it's pushing back on you. So even if I push up against the wall, there's going to be a normal force pushing over to the left. So a normal force is just a compression force. When one thing is compressed, it's going to want to push back, and that pushback is called the normal force. Okay? So it's a compression force or a normal force. And it doesn't have to be horizontal like this. It can be vertical, or it can even be at an angle. The third force is going to be a tension force. Tension force. And tension is the complete opposite of normal force. It is a stretching force. So let's say I was hanging an object from the ceiling. Gravity is pulling it down, but what's holding it up? A string. And so we can put capital F lower or sub capital T or just T. Either one of those works. And so tension is a stretching force. Let's say somebody was pulling a car with a rope. It's a very small car. There is tension in that rope because as we pull it, we are stretching it out. And the rope doesn't want to be stretched out, and so it pulls back on you. So a tension force is a stretching force. We always talk about wires or strings or whatever for tension force. So tension is stretching. Okay, mostly we talk about ropes and strings, but it could be expanded too. Let's go to the back side. for me anyway. Friction force is our last force. Friction force. Friction. Friction is the resistance to an object's direction due to minor collisions with the object and the surface or air. So for example, we all know that if we were dragging a box, once again, we're pulling a box here. If we were dragging a box this way, the friction force, F, lowercase f, or just lowercase f, both those work. If we were dragging it across the floor, there would be a friction force. If I'm pulling it this way, friction is that way. If I drive my car this way, the air resistance is a form of friction, and it's going to be in the opposite direction. Friction always acts opposite to the direction of movement. Okay, and it can be to anything. I said minor collisions. If we took this box right here and we zoomed in on it, and we zoomed in on the box, we would find that the box is not actually flat, but it's actually kind of jagged due to just the molecular structure, and we're going to find that the ground is going to be kind of jagged too. Nothing is perfectly flat. And so you can see here, as we drag one across the other, as we drag the box across the ground, these little indentations, they collide and they grind against each other, and that's what slows it down. Same thing with the air. As you collide into air molecules, they have inertia. Remember that word? They don't want to move, and so when you hit them, they do move. So that is our friction force. Resistance to an object direction due to minor collisions with an object and the surface or air. So it is resistance in the direction of movement. So those are the four basic forces. And all of these diagrams I've been drawing here, these are free body diagrams. These are the diagrams. These are the diagram showing the forces acting on that object. Now there are other forces. For example, if a helicopter was taking off, what's pushing it up? We would call that lift. Okay, that's a force. Or what if I was just pushing on an object? What if I was just pushing against an object right here? We would call that a pushing force, or capital P. This would be capital L, this would be capital P. So there are other forces there, but these are the four main ones that we are going to use for pretty much any problem that we have to solve for in AP Physics. So I don't want it to be like this is the be-all, end-all, but these are all the main ones we're going to use. It doesn't really matter if there are other forces there, because it doesn't matter because force is a vector. And as long as you understand the direction and the magnitude of where the force is being done and applied, you will get it. It doesn't matter if we call it lift, pushing, friction, all that is mute. If you understand that we have to add vectors a certain way, you will get this unit. So 4 types of forces: gravity, normal, tension, and friction.